Unit 6, Learning Target number 3. Calculate measures of center, the mean. So what is the mean? Well, it's not the same thing as we have down here. Here's a quote, be nice, and if you can't do that, just don't be mean, and that is good advice. But that's not the kind of mean that we're looking for. We're not looking for someone who's angry or bad. The mean is a way that we measure the center of data. So here is an example of our graph, and we have it goes up like this and down on the other side. And if we're looking at the center of the data, you can probably see the center is where most of the data falls, where most of the data is. You can see that most of the data is going to be somewhere around in here. This is where the greatest number of things are. Now, if you look over here, we have a completely different shape to our data. You can see that most of the data is not going to be over here. Most of the data is going to be over in this area. So where our center is important. It tells us where most of the data is. A mean is a measure of that center, and it's the same thing as average. So if you were finding the batting average of a baseball player, that would be, the average amount of times that he's going to hit per at bat. So you have this idea of average, and that is what the mean is. It's just the average. Now that we know that the mean is just the average, let's calculate the mean for this data set here that we have below. This is the student scores on Mr. Johnson's math test. We have a 98, a 74, an 87, and etc. How do we calculate the mean? Well, we find the average. And finding the average is very simple. You simply add all of these together, and then once you've added them all together, you divide by how many of them there are. So how many of them are there? There's 1, 2, 3, 4, 5, 6 data items. So we can mark that down. There are 6 of them. So we're going to add all these together, just like it says here, add all the items and divide by the number that there are. So let's pull up our trusty dusty calculator and we'll add all these guys together. So we have 98 plus 74. You can do this on your own at your own calculator. Plus 87 plus 63 plus 28 plus 100. Now, assuming that I've got that right, I can press enter. There's 98, 74, 87, 63, 28, and 100. And now I'll have 450. So I'll move that out of the way. And I know that when I add all the data items together, I get 43. So now I have to divide by the number of data items. There are 6 of these guys. 1, 2, 3, 4, 5, 6. So I'll take 43. And I'll divide that by 6. And I could do that by hand. I could go 6 into 43, and I get 7, 42, and that'll leave me with 1, and then I've got to bring down my 0, and this is going to take me a little while. So, easier for me and easier for you if you just get out that calculator. 43 divided by 6 is equal to, what is that? 7.1666 something or another. Now, most of the time, I am never going to ask you to give me that many decimal points. So you can simply say that this is 7.17, because if you remember, we're rounding, so we have 7.16. We're going to round to the nearest hundredth, which means we look at this number in the thousands place. We know that it's 5 or greater, so we're going to add one more to that one. It's going to give us 7.17. So the mean for this data is 7.17. Let's look at one more example here. We'll calculate the mean in this particular situation. We have 10 families that were surveyed to see how many pets they had. The results are below. So here are my different families, and this family had 5, and this one had 3, and this one had 2, etc. So we've got all these different numbers. We need to calculate the mean. And remember, our first step is always to add them. So we're going to add them, and then we're going to divide by the total number. So just before I start to add, let me count how many there are. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's 10 of these guys. Circle that there. Now let's add them together. Once again, pulling up our calculator. Still got our answer from our last one. We'll clear that out and add these together. We've got 5 plus 3 plus 2 plus 4. You can do this at home, remember. 7 plus 1. You might even be able to beat me at it. 2 plus 1 plus 3 plus 2. Let's see if that's enough. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's how I always check and make sure I've got them all. And then I press enter or equal. And I've got 30. I have a total of 30. So I'm going to put that right here. I added them all together and I got 30. And I'm going to divide by the total number, which is 10. So 30 divided by 10. Now I could punch that into my calculator, but it's a little bit obvious that the answer is 3, right? So I know that 10 families were surveyed to see how many pets they have, and the mean number of pets, the average number of pets for all those different families is 3. 3 pets. Now we can take a look at the graph of our data here. We've got a little graph. Here's the number of pets that we had, and they're all graphed out nicely. And we can take a look at what the shape of the data tells us. So we said that the mean was 3. That tells us that this is where the center is, where most of the data is. So you can see that's right here. This is kind of in the center of the data. And we have more of them in the 2 slot right here. So you can think of that as kind of a weight. It kind of drags it down there. There's my alarm telling me we're almost done. And right over here, we see this guy. He's all by himself. And this is called an outlier. An outlier. You need to write that down in your notes. An outlier. An outlier is something that kind of affects the general answer to the problem really strongly because he's way over here. Even though there's just one of him, he's way over here. Most of our data is here, but the outlier causes this number to go from 2, where it would be normally the center of the data, and it kind of like gravity, it kind of pulls him over here, just kind of drags him over a little bit, and he comes over to to the number 3 instead of having the center at 2. So our center truly is, though, when we calculate the mean, our mean is 3. This just tells you how an outlier affects things.